All right, welcome back, guys. We're going to talk a little bit about Missouri Stream Team. This is a project that we would have done in class. Actually, take a little field trip to get out of the normal classroom and away from school a little bit. So, again, this is kind of talking about the process that we would have done. There will be a YouTube video out there with Kentucky Coffee and Sheila Wallaby actually performing this for you, so you can get an idea of what you would have done. And you may think, well, I'm never going to do this again. But if you decide to go to college or something, they're always looking for volunteer service hours. You might have a local wildlife group or something at college that you might want to hook up with and see if they have some volunteer hours that you can always put on a scholarship or resume. So this is a great way to be outdoors, get some volunteer community service hours. So let's check this out. Missouri Stream Team. Caring for Missouri streams. What is this all about? Missouri has gone forth and created this entire conservation branch called Missouri Stream Teams, where local communities of people can actually get together and clean up their local streams and waterways, which is kind of nice. And not just clean them up, but they can monitor them for changes and stuff like that. And Missouri will conservation will actually take this data, record it, and they will write studies, scientific studies on this and stuff like that, which is kind of cool. And they can go to certain areas and go, wow, this seems really weird, and they can be called in. It's basically kind of like a watchdog type of scenario. So, how do they do this? Well, first, Missouri streams, there's 110,000 miles of streams, and we're talking about streams, not rivers, streams, just little small streams that have water flowing through them. They monitor the health of the stream, which determines things like water quality, so the drinking water. If we were to monitor a stream north of our lake, our reservoir, then we could go, well, hey, there's a lot of chemicals going in there. That could affect your health, which is pretty bad. So we want to be aware of these things. Insect populations. We can say, well, the stream looks really good, it has good health to it, there's lots of insects. If there's not a lot of insects, we might begin to question why there's not. And you might be like, less insects, the better. That may not be the case because a lot of insects also help fish populations. So the fish population itself eats a lot of these small little invertebrates and stuff like that to help them stay healthy. So if you like fishing, you want to be concerned about the insect population. Also, the environmental health. So yeah, water is important to us, as we know, drinking reservoir, but also there could be chemicals in the ground, which then affect our crops, our plants, and things like that, which can have a devastating effect on us, again, if we eat it. So this is why we want to be concerned about Missouri's streams. Okay? So how do we do this? Who collects the data? Volunteers, lots and lots of volunteers. They do not get paid for this. There are people at the Missouri Conservation, yes, they have a job to oversee this, and they get paid by the state, but majority of people doing the hard labor don't get paid to do this. Okay, so 1,000 people just live in Missouri, all ages, anywhere from 2 to 96. Sure, anybody and everybody that wants to help, they can do so. People that care about their conservation and their local environments. I went to a meeting for this, and there were some people there that just wanted to monitor the stream health on their property. That's all they wanted to do, just to kind of get more acquainted with this, and that's perfectly fine. That gives Missouri Department of Conservation lots and lots of resources and data to look into all these streams that flow into other tributaries and things like that. So the cost to join, it's free. All I had to do was sign up and dedicate a few hours of my day on a Saturday to go and check this out. Now, yes, there's more hours involved in actually collecting the data and stuff like that, but it's fairly easy and you're outside. You can sign up for the training. There's various levels of training. Missouri supplies the tools and equipment. So they really want you to do this. They have funding programs for this. They'll give you some tape measures and things and ideas of how to do stuff, just so you can get a better acquainted with what's going on, which is kind of cool. So why collect the data? Because as you can see, these individuals are out here in this photo. They're actually doing things. They got sticks, they got measuring tapes, they got string. They're actually testing things. Why collect this data? The data allows researchers to monitor and watch for abnormal fluctuations in stream health. If there wasn't people like in Flint, Michigan, looking at their water quality, there have been a lot of people drinking lead, high contamination lead, which is not good. So it's important that we see fluctuations like this to figure out what's going on and how we can fix the problem. Provides insight to environmental changes. So maybe it's a new factory moved in. They said they were going to be clean and healthy, and turns out they're not. Predict potential health risk for animals, not just us, but also maybe deer, turkeys, whatever it may be. Things that you like to hunt. That could also have a big impact on them. So that's why we collect the data, is so that we can get all sorts of good things from it. They also do a cleanup. So if you've never walked near our lake or just the roads nearby, walk the shoreline and you'll find you probably can't go 10 feet without finding a piece of trash, which is really sad. We as humans are very careless. We take for granted our environment, the things that we love to go do. We seem to trash those things, and I don't understand why. If you like going there, make sure you take care of it, is what I'm trying to say. Because if you don't, it won't be there in the future. And what you may enjoy there may not be there for your children or grandchildren one day. So keep that in mind. But the cleanups help keep water clean, keeps the fish and insects habitat clean and safe, which help once again stimulate more growth, more fish, which is good, and helps prevent biological magnification. If you're not familiar with biological magnification, we talked about this in biology days, and it's the buildup of toxins in the various trophic levels, which means all these toxins might be dumped on the ground or in the soil, but they eventually get to our water system, which are then uptaken by other smaller organisms that are eaten by fish. And if you eat fish, then you can be ingesting that. And it may not just be the fish, it could be the organisms drinking the water directly out of that pond or lake or stream, like a deer, and you eat the deer. Those toxins are finding their way to your body, which can cause bad things. It could be health risk or even possibly cancer, and that's not good. As you can see, these individuals here, they've gone through and they have special stream team bags. They will throw their, all the trash that they find in these bags, and they find tires, they'll find beer cans, they'll find all sorts of things that you don't even imagine. But people dump them in there. They find their way in there, and it's a pretty bad deal. A lot of the number one thing that people will find is trash bags, like the Walmart bags, the grocery store bags. Those plastic bags wind up everywhere. There are some countries that have even realized the impact on these and have actually banned their use. And I think that's something that you may see in your lifetime is the banning of plastic bags. I think that's going to be a big movement before long that you'll see no more plastic bags because they're also contributing to a large portion of the Pacific garbage patch. That's what's happening. So they seem nice and great, but again, there's not a whole lot of use for them after they're done. Yep. I was looking through Google Images and I found this one, which is Centralia. Centralia actually has a stream team, and their photo wound up on Google, which I thought was really cool because hey, right there, that community close to us. There's no active stream team in Macon County that I know of, but other than ours. So, but if you're looking to do it outside that and start your own stream, go for it. More power to you. Stream discharge. We're going to talk a little bit about the chemical aspect of rivers and streams. So, what is stream discharge? Okay, discharge is the flow of the water, the volume of water flowing past a given point in a given period of time. So, you take the cross-sectional area in square feet, you multiply that by the surface velocity of how fast the water is moving at the top, which is feet per second, and that gets you your discharge in cubic feet per second, or CFS. And that's what we would have calculated with the stream team. Hydrographs show variations in discharge over time. It can show seasonal changes as well. So if you actually had a way to monitor this stream and see how much water flows through there, you can do so. And I'm sure the Corps of Engineers near our lake, they actually have hydrographs that talk about how much water is flowing into our lake and reservoir. So as they think about this, they're like, okay, how much water do we need to let out? There's 17, say, different tributaries flowing into this lake. How do we manage all this water? Do we need to start letting some out? There's rain in the forecast. How many, cubic feet should we let out? And that's how they control the level of a lake. So hydrographs are very important. As you can see here, you look at this and you see some peaks. Probably, you think about the highest waterfall, it's probably in the spring when you have ice melting and also rain moving in. And you have some dips off in the summertime and then maybe some pick back up in the fall or winter with the snow. So there you go. Factors that affect the stream discharge. The soil type. If it's really rocky and the water can move around it, simple, yeah. If it's very clay, it may slow it down or make it very fast too, depending on how wet the clay is. Geology, of course, gradient of the valley slides. So if we think about this, we see the mountains, which again, the water will flow fast down a steep incline, but as it reaches the valley, it kind of levels out. There's just less velocity to it. type and amount of precipitation. So what is it, snow? Is it rain? What is it? That can make a big difference. So if it's just snow, it can slowly melt over time and no big deal. If it's heavy torrential downpours, it could also cause mudslides, as we hear about sometimes in California. The vegetation also plays a big role. If it's just a bunch of pine trees and there's not a lot of vegetation underneath the pine trees, it can cause some mudslides, perhaps, if the trees can't hold on to the soil. But if there's a lot of grass with a lot of deep roots in there, like you see in this picture, it definitely hold the soil in place, probably less erosion. I'm not saying there's not any erosion, it's just less erosion. So vegetation is a very big factor also. Discharge and steepness, we talked about this again as it comes down a mountainside, high velocity. Okay, so as we look at this, we see the size of drainage basin. So we have the time, the discharge. So the discharge peaks right here rather than time, small and large. And then we have vegetation. Okay, we've got discharge and time. We've got bare, which the discharge goes really fast. A forest, it slows it down quite a bit because all those roots are holding on to that stuff and has to flow around the trees and the grass. As we look here, valley side steepness. Again, we're looking here. If it's really steep, you're going to have large, fast moving water all at once. As if it was more of a bottomland, it's going to be very gentle, flowing. It will increase, but it'll go really slow. Soil type, impermeable versus permeable. So impermeable, if it can't get through that soil, it's just going to go right off the top. It's like pouring water on concrete. It don't soak in, it just goes right off. Permeable is as long as the water is allowed to trickle through, like some of the soil that we have around here. It'll trickle into the soil and it'll cause that soil to be wet for a couple days. And that can make a huge impact, so the water won't just travel on the surface, it'll travel through the soil, which will greatly slow it down. Human factors, land use, influence of volume, and rate of runoff. You also have channelization, which increases water velocity. You have dams, which regulate water release, the amount and duration. So the land use influence the volume rate. Yeah. So depends on what you're using the land for. If it's like farming and you take off all the trees and all the grass and you do disc it up and you just plant crops and the crops aren't growing, now you have just a bunch of bare soil. So there's nothing to really slow down a lot of that water other than the percolation through the soil. So that's a big difference. Channelization, increase of the water velocity. Like as you can see in this picture, in cities, they will actually, to prevent erosion, concrete rivers or streams. Yeah. So you might have seen those movies where, like in Fast and Furious, the cars are driving through this big, huge, like thing. There's like a little bit of water and they're driving on the sides. It's like, what is that thing? That's a river. They literally concreted the entire river to prevent erosion from taking away streets and bridges and stuff like that. So was it expensive? Yes. Is it more expensive to rebuild a bridge or a road or relocate people in their houses? Yeah, it's even more expensive because you're going to have to continually do it. You do this once, you're done. So this is the channelization, but it makes the water move really, really fast when it goes through there. So a lot of those movies, when you see the water barely trickling through, it's just not a rainy season. There's water going, but when you have lots of rain in that city, all those drainage systems will uh, divert that water there, and it fills up really fast, really quickly. So kind of a big deal there. But there you go. So there's some channelization problems. Dams regulate the water released, and again, that's allowing certain water to flow out. So you may be downstream of a giant lake or a river, and that depends on how much water they let out. So you might be wanting to go kayak on your local little stream there. Well, if they don't let any water out, you're just going to sit there on dry sand because there ain't no water. But if they let a bunch of water out, then yeah, you can go for it. Back in my hometown, they had a river. It's actually the Sheraton River, and they were downstream of a lake called Lake Raffman, and it regulates the water. And this one guy was wanting to do a float trip, plan a float trip with his buddies, and there wasn't a whole lot of water. So he actually called up to the Corps of Engineers and said that he was the mayor of the town, which he wasn't, and that they were planning a big town festival for a float trip, and they would like for them to release a little bit of water. So he sweet talked him into it, and he's like, "Yeah, sure, we'll release X amount of water. It'll be down there in about 2 or 3 days," which that's how long it took from the water to travel that distance all the way there. And sure enough, the day he had planned his float trip, there was water. It was moving good, and it was great. So worked out well for him, but wasn't really something you should do. But yeah, there you go. So yeah, All right, we're going to stop here today. I'll make this a two-parter, and like I said, I'll actually do all the whole stream team stuff in a little stream that I got nearby, and that'll be a part of the Kentucky Coffee and Sheila Wallaby episodes. If you haven't watched those, give them a watch. I knew you guys probably wouldn't like to listen to these lectures, so I tried to make the videos for those very entertaining and some fun to watch and very short. It's only about 6 to 7 minutes, and they bring up some good aspects that we'd probably talk about in class. So if you haven't watched those, give them a shout. Okay. All right. You guys take care and be safe.